just to introduce to you the basic parent function of tangent cotangent in the video that you need to watch for me for tomorrow or Tuesday, that's where I'm going to deal with how do we handle A, B, C, and D. Okay, so today we're just going to look at the basic parent function, domain, range, period, all the basic characteristics. Alrighty, so if I'm looking at my unit circle, nope, that's not what I wanted. Come on now. All right, there's my unit circle. All right, you see it big and fat. So when we do tangent, we're pulling it from the unit circle. So remember that x here is the angle. Okay, it's not a like x, y, but it's the angle, and we're looking at the tangent of that angle. So look at negative pi. Where's negative pi? That's over here, isn't it? Coleman, join us, please. Negative pi. So, oh wait, what is tangent? Tangent of x is, or I should say theta. Tangent of any angle is the y over the x, right? Okay, so as I look at negative pi and I do y over x, what is that? It's just 0. Okay, now if I go to negative pi over 4 is the same as 5 pi over 4. So what is that tangent going to be down there?
1.
Yeah, it's positive 1, right? When you do y divided by x, they're the same values. Divided by themselves, it's just a 1. Okay. What about negative pi over 2? That's right here.
It's undefined.
So 1 over 0 is undefined. Now, in graphing world, that translates to an asymptote. All right. Now, negative pi over 4, that puts us down here. What's my tangent here? Y over x is going to reduce to what? Good, negative 1. And at 0, what's the tangent going to be? 0. Pi over 4? 1. Pi over 2? 1 over 0, which is undefined, right? 1 over 0 is always undefined. What about 3 pi over 4? Thank you. Negative 1. Let's keep going. Pi? 0. Do we see a pattern?
1.
1, u, then what? Negative 1, 0. It's very repetitive, right? Didn't we see that with sine, cosine? So we're going to graph what we know here, all right? So I'm going to do an xy coordinate. I'm going to start over here at negative pi over 2, pi over 2, pi, 3 pi over 4, or no, it's not right. 3 pi over 2, and then 2 pi. All right, so as I start to graph these things, at negative pi was 0, pi over 2, negative pi over 2, it was, or negative 3 pi over 4, I'm sorry, negative 3 pi over 4 falls right between these two, right? So that would put me up at 1. At pi over 2, there's my first asymptote. At negative pi over 4, that's down at negative 1. Then it goes 0, and it goes 1. And then asymptote. Nope, that's not right. Asymptote's at pi over 2, isn't it? All right, and if I continue on with my pattern, this, another asymptote. So if I start connecting the dots here, I start getting these curves Now this one, we didn't go all the way past negative pi, but do you see the repeating pattern happening? So we're concerning ourselves with one or maybe two periods of graphing tangents. So this consists of one period, one of these things. This is what keeps repeating, right? Two asymptotes in the curve in between. So looking at it, what is the length of this period? It goes from negative pi to positive pi. So what is that length? Did you say 2 pi? It's not 2 pi. Think about it. I'm going half a pi below 0 and half a pi above 0. So that total distance would be 1 pi, wouldn't it? That make sense? So this is one difference. So the period of a tangent graph is pi. So when we go looking for period, it's going to be pi over b instead of 2 pi over b. That is one of the changes we're going to see. All right. Now, as we start doing this, let's do the easy things first, right? We just said the period was the length of pi. What's the range? Where is the energy today, people? Yes, negative infinity to positive infinity. Yes, you know this. It's continuous, right? When you think up and down, it's continuous, so it's just going to be all real numbers. Oh, you can't see what I'm doing. Sorry. I said range. Yeah.
Range is what?
Mm-hmm.
Domain is what?
I skipped domain because we got these asymptotes to mess with now, right? And vertical asymptotes. How do we write this? Well, all right. If I do vertical asymptotes, I could start over here. There's one at negative pi over 2. There's one at pi over 2. At 3 pi over 2. Could I keep going on for days? I could, and we're not going to do that. So what we're going to write is plus n times pi. Or the shorthand, we would start with the first positive asymptote and n times pi. And pi, the reason I picked pi is because that's the period length. So if that changes, this value would change. Okay? N just means any integer. I could do it 4 times, I could do it 5 times, I could do it 12 times. Okay? It's just our shorthand version of that. Now, when we go to domain, it would be every number except where there's asymptotes, right? That would be a lot of little interval notations, wouldn't it? Do we want to do that? No. So we use some abbreviations, and we say all reals except, A-R-E, all reals except. And then I'm going to take exactly what I did on the vertical asymptote, take that statement and rewrite it. So it's x equals pi over 2 plus n times pi. So you start with the first positive asymptote. And then you add n period lengths, however many period lengths you need. So far, so good? All right, so let's switch gears. Let's do cotangent. I'm going to scooch this down. So let's do cotangent really quick like. It's not going to cover up very good. Okay, so at negative pi, we'll stop and think. Okay, cotangent of theta is just the reciprocal. It's x over y now.
Isn't just undefined?
At negative pi, it would be negative 1 over 0, so that would be an undefined. Negative 3 pi over 4,
Negative 1.
it'd be positive 1, wouldn't it?
Yeah.
Positive 1. Negative pi over 2, 0. Negative pi over 4, negative 1. Right? Do you see it?
Yeah.
Okay. Then at 0, x over y would be undefined. Pi over 4, 1. Pi over 2, x over y would be a 0. Negative 1. Do we see a pattern emerging here? Yes. Do we need our unit circle anymore? No. Let's just finish the table using our pattern. What goes next? Undefined. 1, 0, negative 1, undefined. All right. Don't we like patterns here? Okay, now if we graph this, let's see, I go negative pi. I'm going to extend this just so slightly. All right, and 1 and negative 1. All right, so I have an asymptote at negative pi. Negative 3 pi over 4, I'm here. Here, here. Asymptote at 0. Wait, I did that wrong, didn't I? What did I do wrong? Did you see it?
You reversed it?
I reversed it, yeah.
I thought so.
Ah, it's such a Friday wannabe. Okay, so it goes the other direction. Asymptote was right. There's an asymptote at 0, yeah.
Oh,
It's just very sloppy. Apologize for that. Is this an asymptote? Okay. Now, all right, so we look at them side by side. Look, they changed directions, didn't they? Changed directions. What else changed?
There's only two.
Well, we could have kept going.
oh.
We just didn't.
Did the period change?
Did the period change?
Uh-huh.
All right, what's the length of my period here? It goes from 0 to pi, doesn't it? So did the period change?
No.
The period is still pi. It just shifted over. You see that? With regular tangent, it starts over in the negative world, but in cotangent, it starts in the positive. It just shifted over and then inverted, okay? So let's knock this out real quick. Okay, let's do the easy ones. What's range? What's the period? Pi. Don't put up yet. We're not done. Think about our asymptotes. What's our first positive asymptote here?
0.
Okay. And then plus n periods, right?
We can't see.
Sorry. Plus n periods, right?
Just the end.
You can just write n pi. That's fine. And then what would we write on domain?
ARE and pi.
A, all reals except x equals n pi. In the video, I'll show you how to handle x, a, b, c, d. Have a great weekend.